My name is Wendy Ju. I'm a graduate of Stanford University. I received my PhD in mechanical engineering in 2008. Currently, I'm executive director at Stanford's Center for Design Research, and I'm also an associate professor at California College of the Arts. In the research we're doing, we're simulating the future to understand how people are going to behave when we have autonomous cars. And because we don't currently have autonomous cars now, the way that we have to do that research is by creating a sort of theater where people feel like they are in a car and then they behave the way they would behave in an autonomous car. And with that, we're able to design how cars should behave. I have a line of research that's looking at how people are going to interact with robots, particularly in the physical world in our everyday context. And one of the things I'm really looking for is to understand people's naturalistic behavior, just how they're going to behave in everyday life. And so what we have are different kinds of furniture, like a mechanical ottoman that comes up and presents itself to people's feet, a robotic trash can that sails by and offers to collect your garbage when you're eating lunch. And the reason why we made these things is partly because they seem like they'd be fun inventions, but also there are things that we can deploy in environments where people are enjoying their everyday life, behaving naturally, and so the way they're going to behave with the robots is going to be as natural as possible. Very different than if we say, put you in a lab and say, interact with this ottoman. So I think we pick different things where we can actually think about where we can do a field study and understand what natural behavior is going to look like when we have robots everywhere. Wizard of Oz is a technique that's been used for a long time, but the specific term was coined in the 80s. And it's a way of using a person in the loop of an experiment to stand in for a machine. Very often we use this so that we can actually fake some capability. Early on it was natural language processing and generation capability. Nowadays it might be sensing or discrimination or speech recognition capability. In the way that my lab uses Wizard of Oz, we also use the wizard's intuitive ability to act as part of the thing that we're doing. So when we have a graduate student drive a trash can up to people, he might wiggle it a little bit to kind of signal like, oh, you could throw my trash away here. And then that lets people know that the trash can is trying to interact with them. So in our style of Wizard of Oz interaction, the behaviors are a little bit unspecified, and we're using the natural intuition that the wizard brings to the interaction to understand what it is that robots, machines should do in the future. What I'm really interested in this kind of research is thinking about how it is that people interact with one another, and then thinking about how that translates to the behavior of machines. And so the most recent work looking at cars is really just an extension of that. The work that we're doing in cars, the car is really just like a giant robot that you sit inside of, but still the questions are really similar. Like, what are the psychological and sociological, things that people do naturally, and then what does that mean for how we need to design things in the future? So there's a project that we have that's called the Ghost Driver, and in this project we actually have a car that looks like an autonomous car drive on the road and interact with pedestrians. And this is because a lot of the research on autonomous cars is really focused on how the driver is going to interact with the autonomous car, but a really important concern is how that car is going to go behave out in the world. So we're interested to know how pedestrians and bicyclists are going to make sense of autonomous car behavior and how we have to design that behavior so it's clearer. On the Ghost Driver project, we have a driver dress up in a car seat costume and drive the car so that if you see the car and you look over, there's no driver in the front seat that you can negotiate with. And then we look at how people behave when that problem is presented. The early studies we've done right now kind of show that people can be surprisingly confident. Like, I think that they are still willing to walk in front of the car. But we found that if the car behaves unusually, sometimes they go and look, and when there's no one to negotiate with, then they'll walk around the car. Or they'll try to behave in as prescribed a manner as possible and walk very stiffly with the hopes that will be clearer to the car. We think that this is a really good study method that later on, when we come up with ways to show what the car is trying to do, we'll be able to compare how people will behave if there's no signaling to something where you have a good design intervention using this method in the future. I think one thing is that these technologies might not be available on the road right away, but we'll see some versions of increasing autonomy in cars over the next 5 years. If you think about adaptive cruise control, lane keeping, traffic jam assist, like if you put all these things together, in a lot of situations that is autonomous driving, but you're just not allowed to use all those features at the same time in the same place right now. But so those are things that are happening. I think when you end up sitting in a vehicle where there's not a steering wheel, the first time that's going to happen is going to be not on the public roadway, but perhaps on something that's a little bit more like a golf course, or something where you might otherwise see like a electric train or something right now. And I think that will also happen in the next 5 years, but these are going to be really separate for a while. I think, there are a lot of things that are important to study. One thing I really love about engineering is a mindset where people are really interested in building things. And also, I think there's a belief system that obstacles can be overcome. One thing I love about being with a group of engineers is that when they hear there's an obstacle or constraint, everyone thinks like, we can solve that, or we can fix that. And that sense of optimism and can-do, I think is just really inspiring. I love that. I think engineers play a really important role in making the future and inventing things. I think it means that we have a responsibility to think about what should be made and how it should be made. I think a lot of the work that we're doing revolves around how things should be made so it's more comfortable for people. I also think that engineers think about big problems like how things can be designed so it's better for the environment, or safer. So a lot of things, but I think engineers play a really big role in the world that we're going to live in.